In this video, I'm going to show you how I take unstructured text and turn it into structured JSON that a script can trust. It started simply. I wanted a daily email to coworkers with a short developer joke. There are free APIs that return a random programming joke on each request, so fetching jokes is trivial. But two practical problems show up immediately. First, not every joke is obvious to everyone who reads it. A quick explanation lowers confusion and makes the joke more inclusive. Second, some jokes could be sensitive or offensive, and I don't want those landing in anyone's inbox. These two constraints, clarity and safety, mean a naive copy-paste bot isn't good enough. A normal AI chat gives you paragraphs of natural language. That's great for humans, but it's brittle for code. What we need is structure, specifically a single JSON object that we can parse with confidence. So here's the plan. We'll fetch one random joke, we'll ask an LLM to do two things: explain the joke in a short paragraph and classify whether it's safe to send, and we'll require the model to return a single JSON object with exactly those fields. If the safety field is true, we send the email with both the joke and its explanation. If it's false, we simply flag it for a quick human review. That's the difference between a demo and a dependable system. To make this work smoothly, I set up an Azure OpenAI deployment at ai.azure.com and put my API key in a local.env file so the script can read it securely. I install a few Python packages, then I import the libraries, create a client with the endpoint and key, and define a system prompt. The system prompt is the heart of the reliability here. It tells the model to return a single-line JSON object only, with exactly two fields: explanation, a short string, and safety, a boolean true or false. No extra prose, no markdown, nothing that would break a JSON parser. Keeping the system prompt separate also helps with performance and cost because the KV cache can be reused across requests. Next, I fetch a joke. The joke's API returns a setup and a punchline. I combine them into one string for the model. Then I call the chat completion with two messages, the system message and the joke. When the model responds, I take the raw string and immediately parse it with json.loads. If parsing fails, that's a signal to log the output and treat it as unsafe by default. But with the strict system prompt, you'll see that the responses are consistently valid and easy to parse. Now comes the decision. If safety is true, I compose the email, the subject, daily dev joke, the body with the original joke and a short explanation, and then I send it. If safety is false, I don't send it, I flag it for review. The point is to combine model judgment with a simple rule so you get the best of both worlds: the model's ability to interpret language and your guardrails for what actually goes out to people. This blend is how you maintain precision and recall in a setting where tone and context matter. Let's walk through it end to end. Fetch a joke. Ask the model for an explanation and a safety classification, with the JSON requirement baked into the system prompt. Parse the JSON, check the boolean, and either send or flag. What you'll notice as it runs is the predictability. Because the output is JSON, downstream code is simple. There's no brittle regex, no scraping of paragraphs, no guesswork. And the explanation makes the content friendlier for readers who might not be familiar with a particular reference or pun. Why insist on JSON? Because natural language is ambiguous, and automation hates ambiguity. A single JSON object forces a contract that your code can enforce, test, and log. It also makes auditing easier. If someone asks, "Why was this joke sent?" you have the joke, the structured explanation, and the safety verdict right there in your logs. If something is flagged, it never reaches inboxes until a person clears it. That's the difference between a fun demo and a system you can trust on a weekday morning. To recap, we turned unstructured text into structured data, added a lightweight safety gate, and automated the final action. The result is a pipeline that's automated, auditable, and safe. In the next video, I'll dig into how keeping the system prompt separate lets you reuse the KV cache to save cost and reduce latency, plus a few tips for production like retries, timeouts, and observability. The link to the code is in the description. Give it a try, and if you hit any issues, drop a comment. If this was helpful, like, share, and subscribe for more practical AI automations that actually hold up in the real world.